Hello everyone, welcome to week 5 of Grasshopper, and this week we're actually going to be introducing a plugin called Ladybug, and this is on the Canvas site. And if you click, if you click on the Food for Rhino or the Grasshopper group links, you'll see it's actually a couple of groups of user components that comprise this. Ladybug is for environmental analysis. Honeybee is more for linking to some of the other energy plugins. So Ladybug, as you can see, works with weather data, and you can use that to generate radiation, solar analysis, psychometric charts, and comfort analysis. Right. So this is a kind of really rough, broad overview. Now there's tons of options here, but these are the basics. One series of the tutorials you'll see today here, where you see weather data and environmental visualization. And this is actually a YouTube series done by Chris Mackey, one of the guys who's working on Ladybug. And he shows you essentially how to do most of these. The psychometric chart, the sort of charts, and basically taking weather data, importing it, visualizing it on a chart, some path, wind rows, psychometric chart, that sort of thing. Right? So you can watch these. These are not very long. Maybe some are like just 8 minutes, some maybe 12 minutes. Right? So these are each has a very specific topic. Right? Honeybee is more for linking to building energy and daylighting simulation. So you'll see like OpenStudio, Radiance, Dasim, Energy Plus. Actually, it's these sort of other peripheral programs. It kind of uses those simulation engines and does more interiors and energy simulation, right? And this actually, Honeybee, a lot of the functions I'm not going to touch because this really goes into environmental tech territory a little bit too much for this class. Okay, now there's more sort of description here, and there's a really quick sort of 4-minute run through of like what can be done in this video or on this web page. Okay, now up front you'll see here, as with last week's unroll component, for this to work, you also need to have GHPython installed. And so you will need to, if you don't, or if you're working on one of the lab computers, you might check and see that this is installed. Make sure that once you put the GHPython GHA file into the components folder, you go to the folder, right-click the file, check properties, and unblock it if it's blocked. Right? That's important to get it working. Okay. So what I will actually put on there is, and besides these, because these are just visualization basics, I'm going to show you, I think maybe 3 or 4 of those sort of most useful things, at least at this stage, and just show you how to do that from scratch really quickly. Right? So this file is a mock site file, ladybug intro.3dm. This will be uploaded and you'll have access to it, or you can use something of your own if you want to try it out. Okay. So make sure that you actually go through this part of the tutorial, getting started with Lady, installing it. But it's actually pretty simple. Once you install it, there's basically, when you download it, it's a zip file that has a folder, and that folder essentially has hundreds. I think there's like, I don't know, 250 of these user files, and you can just say drag and drop this, select them all, or unzip them, and you just drag and drop them into the Grasshopper canvas and let go. Right, and that's it. So it's pretty simple. You can also look at the installation instructions text, and basically, for the most part, you just need to follow the first 4 steps, or first 5 steps, right? We're not using honeybee here, so you don't need that. You don't need dasim or any of those at this moment, or radiance. So yeah, follow this. You might actually need to do this sort of uninstall thing if you have an older version, just to kind of remove it. So that's here as well, okay? Just to make sure that you're on the same page and things are working. So if things are working, what you will see is this. You'll have a tab called Ladybug, and you will have a tab called Honeybee as well. You can ignore Honeybee for the most part. As you can see, if you kind of look at these are more for energy simulations and all that stuff, right? So that's sort of out of our purview for now. Alright, so this is a Ladybug. It looks overwhelming at first, and there's a lot of stuff, there's a lot of options because they built in a lot of customizability. But if you take a quick look, you basically say, well, let's say we want to analyze some weather data. These are the ways I can visualize it. So you'll see, you know, outdoor radiation rows, sky dome, sun path, and wind rows, right? These are all some of the visualization options. Environmental analysis. There's a view rows, which is interesting. The two we'll be looking at are the radiation and the sunlight hours analysis. But there's also others, solar fan, solar envelope, which is actually might be more useful for D7. Actually, this one, the solar envelope, might be more useful for urban environments like D7. Alright, so there's a couple things, but to start out from scratch, what we're going to do is just to start out first here. And the first component is the Ladybug component. You drop it in, and you can double check that it's working by putting in a panel and say, oh, okay. So this is the default app. This is where it'd be saving any sort of data that Ladybug is working with, and it will show you that. Okay, so that's the first step you want to do. Make sure that that's working. All right, the second one, and these are the three sort of options we have. So you can download or import an EPW file, which is a weather data file, right? And now, there's two ways to do this. I'm going to show you this one, and then I'm going to show you this one. These are two different ways of getting a weather file, and there are advantages to both. This is basically this. With this version, you need to be online. With this one, you can download something in advance. Okay. So it's looking for what, a Boolean value here, and you can actually copy paste another panel. So let's give it a Boolean toggle. And once you give it a Boolean toggle, and let's say you double click, say true, it'll actually bring up your browser and take you to the Energy Plus, this is the DOE website for weather data. Okay, so let's click through North and Central America, USA. I clicked on Georgia before. And in your guys' case, if you're looking for Savannah or Charleston, let's see. If you're looking for SC, South Carolina, then you'll find Charleston. Okay, so you know, this is sort of based off of geographic location. So there's a zip file you download, save it as a zip file, 5, save it here. And if you open the zip, there's 3 sort of different files, and you can just unpack them to where those are. So I am going to just unzip these into the folder. But the only one we're really using is this EPW file. This is the one that Ladybug works with. Alright, so there's that. Let's go back to Rhino. So that helped you download it. So this is to help you download it. This is just to kind of kick things off. So let's look at the next one. Open EPW weather file. So this is the way you open it. right? And on the left, this also needs a Boolean toggle. So let's just copy paste one in. Put this over here. Okay. And toggle it to true, and it'll actually tell you to look for it. Okay. Now mine is in here. It's visual Ladybug. So this is the Charleston one that I just downloaded, and say open, and I'll say if it works, then it'll give you a path. Okay. So this version, opening it, downloading it, opening, this is sort of step by step, right? So this is pretty easy to understand. Now, however, because let's say if you're sending your Grasshopper file to someone, and then you would you have this linked, then you would actually have to send them the EPW file, or they have to download it themselves and do this sort of whole thing again, right? So there's actually a different way of doing this. This is kind of a method where you can stream or automatically download it from a URL. Right, so here it's asking you for a URL, and it actually gives you instructions. You right click on the zip link and copy link address. Okay, let's actually go back. Let's not do SC. Well, yeah, you can do SC if you want, or we can do. Let's go and do Georgia, for example, and Savannah. Okay, so Savannah here on the zip link, I right click and say copy link address. All right. I'll minimize this, come back here, I'll use a panel and double click in there and just paste in the link I just copied. Don't hit enter, just like click outside, and that's the link you want to give it. You give it that. So it'll think for a while, it'll go upstairs, it'll go online, download it, unzip it, and just put it here, right? So this is sort of more automated online version of getting the EPW file, and when you send people this Grasshopper definition, then when it opens, it'll just go online and grab it automatically, right? But the downside is that if you don't have internet access, then you're screwed, right? So that's just something to consider. Okay. So this guy, I just pulled it in, but that's open EPW weather file. Oops, sorry. That's the import EPW file, which is this one. All right. This is only if you want to, let's say, for example, we have Charleston here, we have Savannah here, right? You can push, let's say, Charleston into here, and it'll think for a little while. And this actually gives you a lot of the sort of relevant information related to latitude, location, where it is, time zone, blah blah. Temperature information, which it's a long list, right? Hence these visualization options, right? So these all more or less kind of correspond to weather data that you can visualize using one of these things, like the radiation, or analyze weather data, or if you want to look at temperatures or humidity, that sort of thing, right? So that's what all that stuff is for. So in our case, we don't need that right now. What we want to do is actually we eventually want to get to this radiation analysis, because that just kind of shows us how much radiation or solar heat gain your building is getting, right, in a certain given context. So we can plop it in and see just really quick. It needs a couple of things. So it needs a selected sky matrix here. In particular, it needs geometry, it needs context. This upper part are some of the helpful inputs. So before we get to there, we'll actually need to go here and run this Ladybug Generative Cumulative Sky Matrix. and this uses radiance's function to calculate sky radiation. All right. So this actually, you can see it's asking for an EPW file, which we can give it, right? So let's give it, in this case, let's give it the Charleston one. Sky density. This basically only has two options, a Tregenza sky, and actually that's going off, a Tregenza sky, which is a sort of coarser subdivision of the sky, and a Reinhardt sky, which is a finer density sky. This kind of makes it, well, with a higher density, it'll take longer to calculate, basically. Okay? All right. So you have this. Let's give it another Boolean toggle. In this input, run it. Okay? So let's not change that for now, although we can sort of be more explicit and say 0 if we want. And just so we know that eventually we know what density we're working with. Okay? Now, you'll see that when I toggle this, it'll run this. And it will take well, I think for me it took maybe 30 seconds or so. It took 30 seconds or so to kind of calculate, or maybe a minute. But let it run. It's basically calculating based off of your location and the weather data. It's calculating the sort of radiation data, the sort of sky radiation info that comes from your weather file. So it'll take a little while, and once it's done calculating, it will actually save the information somewhere. So, and your screen might sort of stall and need to think for a little bit. Just let it do that. All right. So once it's done, it will actually kind of save that stuff somewhere, and then basically, if you hover over the README, then it will say, okay, that's working, and then there is something here, right? Okay. So that's the cumulative sky matrix. Now, you'll notice that basically you can kind of match inputs and outputs. I know there's a lot of stuff here. But you can basically hover over and say, oh, well, what does it do? What it's looking for next, right? So if I'm hovering over this, the description actually tells me, use the select sky matrix component to select the desired sky matrix for use in a radiation study, radiation rows, or sky dome visualization. Okay, so it was actually just underneath it, right? It's the next component down, select sky matrix. So this matches this, right? So you can push that in right away. And here, it basically gives us some options in terms of which hour of the year you want to analyze, or you want to do an analysis period. And let's sort of ignore these for now. Now the analysis period one is actually important. It says analysis period from the analysis period component, right? So let's look for here under the first sort of cluster, analyze weather data analysis period. This is the one you're looking for, and obviously this goes into there, but actually let's look at these first. So this basically says from January 1st which hour to February 2nd which hour, and that's the sort of period of analysis that you were looking at or you're wanting to look at. So this is actually pretty simple. We just make some sliders, month 1 to 12, day is 1 to 31, so 1, 31, these are all number sliders, right? And then hour, I believe, is 1 to 24, so 1 to 24. Okay, and actually let's just copy those. Do that for the bottom group as well. Now to give you start and end time are identical, I have no idea what you mean by this, right? Because everything is 1, right? So let's do 5. Our inputs are the same. So for the hour, you might need to add, let's say to midnight, right? Now if you're wanting to look at the whole year, or in this case, or let's say half a year, so let's do that, right? So that would be essentially the analysis period would be January 1st to June 30th between hours 1 and 24. Okay, so that's analysis period. Push this into analysis period here, and that's your selected sky matrix. So this goes into selected sky matrix like that, and we're almost ready. Geometry and context, right? So in this Rhino file, you'll see geometry, which is your project, whatever it is, and then context, right? So these are all BREPs, boundary representations. So let's go to the params tab, geometry, and pull in a BREP container and copy it actually. So the first one I'm just going to rename geometry, and the second one I'm going to rename as context. And I'm going to link in set one BREP, geometry. For the context, set multiple, and just select everything else around it. Okay. And let's see, push this into geometry, push this into context. All right. The north is going to be in the y-axis by default, whichever direction your y is, although you can set this on your own by giving it, a different axis or a number between 0 and 360. If I kind of pull this in so you can read it, right? A number between 0 and 360 that represents the degrees off of the y-axis to make north, right? Or you could say I want to put in a vector. So vector component, right click, set one vector, and just say draw your own direction, whichever direction north is, right? So let's say if north is actually that direction, then you push in that vector, and that's that. Okay, two more inputs. Grid size. This is the size of the analysis grid that it will analyze. So the smaller the grid size, the longer it will take to calculate, and vice versa. For this model, let's just do 5 feet for now. You can change this afterwards. Doesn't make a difference. Distance from base, this is a small offset number, so we just want something like this, 0.1. Distance from base. Okay. Run it is a Boolean toggle. And then parallel, if you have a multi-core CPU, then setting this to true will let it run faster, right? So I want that. And that's it for now. Okay. So let me try to do this. So I'll toggle this to true, and it will probably run for a little bit. And you'll see something pops up. Okay, and these will give you actually solar radiation results. I'm going to hide these so they don't get in the way. And you'll see, even I guess if I hide my Rhino geometry, you'll see that this is a essentially a 5 foot by 5 foot grid that shows you on the right. So this is the analysis, kilowatt hours per meter squared. Radiation analysis, January 1st to June 24th, I'm sorry, June 30th, midnight, right? So for half of the year, that's what the result will look like. Now, if you change this, obviously, let's say, let's change the month to the full year, so you want to do 12. Oops. Yeah. You might have to disable this and run it again, and that will give you the full year, right? So essentially by kind of changing this, you can easily control, the interval of the analysis period that you're working with, first of all. And then second of all, you can use this grid size to control how detailed the analysis becomes, right? So here I can change this to something much smaller, let's say 1. And you'll see that it'll take a little while to update. But then you get much more finer results in terms of, okay, which sides are getting what type of shading. If you're feeling like things are getting in the way, you can always hide them. And let's say get the context geometry back. Right? Now, if you're not seeing these red lines on your mesh, this sort of mesh representation, go to Display, Preview Mesh Edges, or Control M. That turns that on and off. Right? So that just, depending whether you want that, whether you prefer that or not, that's what it changes. Okay? So display, I like to have my mesh edges on because I can see what's going on. But so you'll see, on some of these faces you're getting different. Some of these are kind of obvious because they're in the sort of shaded direction. Okay. All right. And for the outputs, you can. There's a lot of sort of different ways, but usually these are meshes. These output meshes are meshes, so just use a mesh container. For example, if I hide this, then you'll see, and you can just like try pulling these in and seeing, okay, that's the context. This is the analysis mesh that we had. But if you need the radiation results in color, then it has to be this, the radiation mesh, right? Okay. So this is the data, but this is the visualization of that data in color, according to this sort of legend. Now, if you go back to, I forgot which one of these videos that actually shows you how to change the color of this legend, and that actually uses this legend parameter, and you can kind of change what color is what color represents what, but I won't get into that here. So yeah, that's the first simple radiation example.